So in this video, what we are going to see is the following: the minimum number of binary links in a constrained mechanism. Okay, constrained mechanism means the degrees of freedom is 1. Okay, so the constrained mechanism with simple hinges. Okay, so what's the minimum number of binary links? So that's what we are going to identify. Okay, so in a mechanism, or at least in a constrained mechanism, we can't have a singular link. We have to have at least a binary link. So let's call n2 is the number of binary links. Okay, and n3 is number of ternary links, and n4 means number of quaternary links, and so on. Okay, now what is the total number of link, which we shall represent by n, which is equal to number of binary links plus number of ternary links plus number of quaternary links up to say ni. Okay, which is the number of links which has been connected with I other links. Okay, now how many hinges will be there for such a kinematic chain? Okay, now let's say if we have a binary link. Okay, so if we have binary link, a binary link will have 2 hinges. Okay, so let's say 2n2. And what about ternary link? The ternary link will have 3 hinges, so 3n3, and like that up to I ni. Okay, but if you see, the hinge will be connecting 2 links, right? And therefore there is a therefore if we use this formula, we are calculating the number of hinges twice. So in order to adjust that, what we will do is we will either divide this whole thing by 2, or we will multiply 2 with j. Okay, so that represents what's the number of simple hinges for this system. Okay, now this is n and this is j. Okay, now we know for a constraint mechanism we have to satisfy Groupless criteria, and let's use these two equations and put it in the Groupless criteria, and we'll see what we get. So let me write Groupless criteria for the reference, which is 2j minus 3n plus 4, which is equal to 0. So we know 2j, so 2j is 2n2 plus 3n3 plus dot 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 plus I ni. Okay, and minus 3 into n, 3 into this one, right? So which is n2 plus n3 plus dot 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 plus ni. Okay, and plus 4 should be equal to 0. Okay, now if I rearrange things, what I will get for n2, because n2 is what I need, right? So because minimum number of binary links, so we have to calculate the number of binary links. So the number of binary links is equal to 4 plus n4 plus 2n5 plus 3n6 plus dot 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 plus I minus 3 into ni. So this is what I will get, or in short I could rewrite as 4 plus summation of k is equal to 4 to I k minus 3 into nk. Okay, fine. Now if in a kinematic chain, if there aren't any n3 or n4 or n5, anything else other than binary, then this thing will be 0, this term will be 0, okay, and the minimum number of binary links will be 4, okay. So that's n2 min, okay. And one example, we know that it's a 4-bar mechanism, right? Okay, so that's about minimum number of binary links in a constraint mechanism with simple hinges. Okay, now let's go to the next topic, which is maximum number of hinges on one link. Okay, maximum number of hinges on one link, which actually represents I, okay, and that is in a constrained mechanism, okay, with n links. Okay, if a mechanism is having n links, then what is the maximum I value it can have? Okay, that's what the maximum number of hinges on a single link. Okay, so what we need to identify is, for a given n, what is I? Okay, so that's what we need to identify. So in order to identify, what we are going to do is, we are going to look at this mechanism. Okay, say there is a mechanism or a kinematic chain with I hinges. Okay, I hinges. So now how are we going to do is, if a mechanism has to have I hinges, then what should be the n? Okay, so from that we will be answering our question, that if we have n links, then what will be I? Okay, fine. So now we have a mechanism with the link which is having I hinges. Now so these are the hinges, 1, 2, 3 and dot 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 up to I. Okay, I hinges. Now these hinges are being connected with other links. Okay, so this is 1, and then this is 2, this is 3. Okay, and we have quaternary links, sorry, not ternary links, otherwise it will not be a simple hinge. Okay, since we have to have only simple hinges, therefore we have ternary links over here. Okay, so if we count the number of links, for each hinge there will be one link. So that's what 1, 2, 3 dot 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 up to I. Okay, so I links are connected with this link in I hinges. Okay, now so there should be, in order to have a mechanism and in order to have a constraint mechanism, we have to connect this link to this link and this link to this link. Okay, for that we will introduce a new link. We'll introduce a new link, which is this one. That's an I plus 1th link, and this link, which is an I plus 2nd link, and like that. And finally we will have this link, which is I plus I minus 1, which is 2I minus 1. Okay, so now let's calculate how many links are we having in this kinematic chain. So in total it is 2I minus 1. Sorry, 2I minus 1 plus this link, right, plus 1, which is totally equal to 2I. Okay, so from this what we can say is that will be our I max. Okay, so I max is equal to n by 2. If n links are there, okay, then a link with I hinges where I will be the I max, which will be n by 2. Okay, so that's the solution for the maximum number of hinges on one link in a constraint mechanism with n links. Okay, now is it really a constraint mechanism? Let's check. So how to check for the constraint mechanism? We have to use the Groupless criteria. Okay, let's see. So 2j minus 3n plus 4 should be equal to 0, and we need to see whether this will be satisfied. So now we know what is n, which is 2I minus 1. What about j? So the number of hinges, right? So let's see the number of hinges. So if we count all these hinges and the and this link, okay, that's I. Okay, in addition to that we have hinges over here, 1, 2, 3 and 4, 5. So okay, now let's count it like this. This is I, and then if we see here for this binary link, we have two binary links, so that will count to 2, plus for quaternary links we have so how many quaternary links? Okay, let me calculate it in this manner. So how many j1, no, it's not j1, sorry, you should not count it like this. So j is equal to I, which is for this these links, sorry, these hinges, plus this hinge and this hinge, which is plus 2, plus these hinges. Okay, so these hinges are on the ternary links, and how can we account, which is I minus 2 into 2, okay, into 2, so which is equal to if I max, okay, I plus 2 plus 2i minus 4, okay, which is equal to 3i minus 2, right? So that's our g value, okay. So 3i minus 2, okay. Now let's substitute. So what we will get, 2 into 3i minus 2 minus 3 into 2i minus 1 plus 4, and which will be equal to 0. Irrespective of the I value, it will be equal to 0. Okay, so it's a constraint mechanism. Okay, thank you.